So, in the next few minutes, I'm going to give you a dance that'll help you remember Ekman Transport in the oceans. Now, the way this dance starts is the way all ocean currents start. Starts with wind. And the wind is going to be coming from me to you. Now here in California, we are in the northern hemisphere. And when that wind pushes on the ocean, there's two sort of forces affecting the motion of the ocean. You have friction, which is pushing the ocean this way, but then Coriolis force deflects the flow of the ocean water 45 degrees to the right of the surface water, represented by my arm, 45 degrees right to the direction I blow. Now this surface water is pushing on water in upper intermediate depths, and at some point, at some depth, water is flowing. You have again the combination of friction and Coriolis force, and the water at depth is flowing 45 degrees to the right of the surface current and 90 degrees to the right of the wind. Now this intermediate depth water is also pushing on things. It's pushing on the deeper water. The deeper water is being put by a combination of Coriolis and friction, is going a little bit slower than the intermediate water, a bit slower than the surface water, which is also slower than the wind, moving at about 45 degrees to the right of this intermediate water, represented by and its direction is represented by my knee, which is 135 degrees to the direction of my wind. We'll finally get all the way down, and at some point, water's barely moving, and it's moving in the exact direction opposite the direction of the wind because of the combination of Coriolis forces and friction in the water column. And the net direction all this water is going to go is the direction I fall. 45 or 90 degrees to the right of the direction of wind. And that is the direction of net transport. If you wish to do this dance in the southern hemisphere, simply reverse what I've done, and you will fall 90 degrees to your left.